This set is turning out to be a little bit more of a challenge to align than I expected. Part of that, though, I've just figured out, it's just me being a little slow, is that it's because the directions are backwards for one of these coils. Well, I shouldn't say the directions are backwards, it's that the set is now backwards. It's because of this, which is the sound discriminator coil. They said to adjust the top for peaking at 21.25 megahertz and the bottom for symmetrical waveform around 21.25 and set it to null for 0, so you get the typical FM receiver type S-curve. I could not get that to happen, then it dawned on me, that's because this isn't the bottom, this is the top, and this is the bottom from what the alignment instructions call for, because the earlier version of this chassis, that coil was mounted on top. They moved it down below because of the rectangular picture tube. Imagine this had a round picture tube. There'd be no problem to have that coil up here, nor would it hit this tube. So when they went to the 16s, they must have realized, ah crap, that coil's not going to fit, and they mounted some standoffs and flipped the coil and mounted it down below. And they probably should have done something about this tube as well, but I guess they couldn't for some reason. But I have seen some chassis with tubes mounted underneath the chassis, believe it or not. But I guess they figured that even with it bent over, it was making good enough contact. And you can see how there is a collar for a tube shield, but with this shield on, you can't get the picture tube on. I just put it on here while I'm doing the alignment to prevent any interference. And when the picture tube is installed, this tube gets bent like that, and there's no way you could have a shield on there. Unless you could bend it back as well. So, I think I'll have better luck getting the S-curve now. I'm going to hook up the equipment and go through it. I already went through it once, and the sound is not very good. So now I'm thinking that, the coil, I had that backwards, so I'm going to try going through it again and hopefully get better results. So here's how that S-curve currently looks. Not too bad, right? But let me put on the marker. That's the marker for 21.25 megahertz. It's supposed to be over here. That's what I meant by me having trouble with that coil and things not being quite so right. So, before I was adjusting it down here to try to move that center point, but really, it's what's up top now. So I get the tool down in here. And tweak that a little. See, now that moves the center point. So it's crossing over 0 now, 21.25, but it's not exactly symmetrical, so we can use the other one. Also helps get the marker right on the axis there. Now I do the top side, then adjust the symmetry. It's killing the gain a bit though, so I think I need to go through and retouch up all the coils. So the one down here, one over here, top and bottom, that's the IF. You want to adjust that for maximum gain, symmetry, and wide bandwidth. And then this is the discriminator coil that you want to adjust for maximum amplitude and symmetry, about 21.25. So I'm going to go through this whole thing a few times. And they interact somewhat, especially on this last can, so you kind of need to go back and forth and back and forth. Yeah, it's getting better and better. Just want to touch up the other, so I'm just going to briefly do this. To really do the earlier stage IF, I should move my scope back to an earlier point before the discriminator, but I'm just going to quickly do this to see if it has an effect. So there, I'm going off peak. So actually, well, maybe that isn't so bad actually, the way it was. Bottom one here a little bit. Yeah, didn't affect the amplitude really any, so they probably aren't too bad, but definitely go back and check those, see if I can get the scope in the right spot. Which I think it is here. And because there's less gain at this stage, I got to crank up my input. Make the marker a little smaller too. Oh, there it is. Yeah, it's off a bit. So it should be peaked where that marker is, and shouldn't be quite so wide and lumpy. I can move the marker around to see exactly. They tell on the alignment instructions it should be. Is it 250 or is it 350? 250 kilohertz wide. So you can go plus minus 125 from 21.25 and do the math and figure out. Alright, that's pretty good. Certainly better than it was. Now, something else you need to be very careful about, and I pointed it out luckily on the service info, is to keep the sweep rate very low. It's got to be below the line rate, which typically, especially for vintage sweep generators, they use the line for the sweep frequency. Notice mine's flickering. That's because I have it set much lower. There is a way you can compensate for that by installing a heavier load resistor. There's a 470K right now that I'm going across, and they say you can put a 5.6K in there. But just using it as is. So notice right now it's centered about 21.25, and it's a pretty good looking flat hilltop with the wide bandwidth. Now watch what happens when I increase the sweep rate of my generator. Not touching anything in the TV, same frequency, same everything. I'm just changing the rate at which it's sweeping from the low to high frequency. So less flicker, but notice how it's dramatically distorting what we're looking at. It's shifting the peak from here over to here. So if you were to use this sweep frequency, if I'll just go over the line, it looks like it's way over here. So imagine if I was using this sweep rate and I peaked it over to here when it's really supposed to be peaked over here. You'd still get some sound coming through, but it'd be nowhere near what it's supposed to be. So there is actually the true response of this circuit. So you should really be careful when you do this and go with the lowest rate at which you can still make out the response. And notice that I've gone even slower now that things are looking a little differently. So I'm going to go back and peak that up a little bit more. Now, something else I wanted to point out is that marker. Notice how it kind of looks like a dumbbell. I was playing around with the marker settings. I'm just going to go with a higher sweep rate for now so it's more apparent. Get in here closer. Increase the marker size a little bit. So it looks like two kind of lumps there. Well, this generator, WaveTech 1002, and it's similar to other members of the WaveTech sweep generator family, is you can change the sweep size and width and tilt, which is why I really like this generator. So here's a really wide marker. It's middle, and here's narrow. Well, when you really got a very wide sweep width, so when you're doing these IF, you're really not sweeping off all that large a frequency range. Your marker gets kind of hard to look at. So, like, where is the center of that marker? So it generates the markers by feeding in another frequency. In this case, I'm feeding in 21.25 fixed RF, and it's heterodyning against the sweep generator, and it makes a little squiggle here. The null is where the frequencies are exactly the same. It's a little hard to tell. But when you go to this, the null point is more apparent. It's the center of that mess. And the sweep size changes the amplitude of those squiggles. And finally the tilt. Not so useful in this application. It's just really hard to tell what's going on. But if your marker happens to be like on a vertical rise, I'll dial in something like 22 megahertz. Nope, not quite right. 21.5 maybe. There. So it can be a little hard to tell where your marker is when it's on a vertical rise there. So if you pull this knob out, you can tilt it around. It's kind of nifty. You put them, actually adjust the slope of the marker so that it's now the same as if this line were horizontal. So if you can find a 1002 or 1001 or 2001 or 2002, there's a bunch of these. Nice to have. Nice to have. Most sleep generators, this is all you get, the squiggle, and that's it. You can't tilt it, and you can't change the width like this. Well, I think I've got this one just about all wrapped up. I wanted to give you a final look at things underneath the chassis before I tip it back down. I tried both AGC settings on the tuner and ended up putting it back where it was originally, which was grounded. And I want to also point out that I did replace the caps right off the AC line with safety rated ceramic disc capacitors rated for AC line operation. And I didn't need to add a fuse because it's already got one. So I think things are all wrapped up underneath the chassis. As for the top side of the chassis, I've got the recoated replacement CRT installed. Put all the cardboard tubes back on the caps. And I received a question asking how I secure them if I glue them down. No, there's generally enough tar residue inside, and they're pretty snug fitting on the base to begin with. So between the cardboard being fairly tight to the metal rim around the bottom and a little bit of tar, they stick on there pretty darn solid. And if they don't, I'll scrape a little tar, chip some out of the inside near the top and put it around the base, maybe heat it up a little and then push them down. So they're on there pretty solid. Here's the new high voltage lead with the old cap install. You can see now why you want to not coat the bag around here. You want to leave plenty of clearance so there's no arcing, and the ground strap is securely pressed up against the coating there to form that high voltage filter cap. So let's give it a try. I want to clean up these knobs too and track down a spring for this one. I remember when I was pulling out the knobs, some of these clips fell out. Oh, there's the sound. And I thought I'd picked them all up, but I think I might have missed one. Those little springy clips that fit inside here. This knob doesn't actually do anything though, because this is just the volume power. There's no additional functionality unlike these, which serve two functions. Alright, so I spent a frustrating hour or so fiddling around with the ion trap magnet, the centering magnets. Still not 100% happy. Clearly it's tilted a little bit up here, whereas it's straight here. Problem is, if I adjust anything, I start getting a shadow in this corner or this corner, which is a common issue with these CRTs, especially the early rectangular ones are especially problematic. So you move it a little bit and it gets dark. And if I move it in even further, so you really get dark shadows over here. Which is a pain because the other side looks even better. You get sharper, crisper on the other side, but you lose those corners. This makes me wonder if this, you remember these were the first generation rectangular CRTs, if they hadn't quite perfected the technology yet. Anyway, so here's the bandwidth test pattern. And this is kind of interesting to do with a continuous tuner because you can very clearly see the effect as you move the local oscillator around. How you start losing things as you tune through the band. It fades out, and there's picking up a sideband. with no audio, and then it's gone. Sound is fantastic now. This is all the way down and I can still hear it a little bit. Plenty loud. I need to go back through the service info, or rather the riders, because they tell you how to adjust the contrast and the brightness. It's a little bit different from what I'm used to. Just notice how as I dim things down, they get sharper. There's something about turning the brightness down a certain amount, and turning the brightness all the way up, contrast all the way down, something like that. The gist of it is you want to keep the contrast as low as possible, so where you can get a good picture. And as far as the bandwidth goes, it's not bad for a 50 set. You can still get some definition out here. These weren't quite as wide a bandwidth as the earlier sets. I started limiting the bandwidth because of color TV coming out and chewing some of it up. But anyways, check out a couple other test patterns here. Circles, good for checking linearity and centering. Let's see, things still aren't quite right. Should be more off to the right a little bit. You really need to have a good test pattern generator to do stuff like this. So you see how this corner is being pulled up and twisted a little bit. So it's really the last issue that I'm fighting with. Otherwise, linearity is pretty good. Vertical is very good. Horizontal is a little bit scrunched over here. I've adjusted the drive control, which has a pretty strong effect on the linearity on the left side. And the right side, there's a coil sticking up on the top of the chassis. I can tweak for that. Get rid of that annoying tone. Right now, I'm going to feed in some programming material. We need to see how the set's playing. So aside from the annoying issues with the screen being off center, pulled a little bit, it's playing very, very well. The thing I find really annoying is with these local over-the-air channels. A few weeks, maybe a couple of months ago, they shifted the formatting of the broadcast material, whereas it used to be 4:3 format and filled the screen. Now it's sort of double letterboxed, so you get a windowing effect. Might be a setting in my converter box. I have not tried looking through it. But Me TV, Hero, and Icons, they're all doing that now. U2. So it's hard for me to find any channels now that fill the screen. And they all seem to either be letterboxed or the double letterboxing effect. There we go. Here's a channel.
For your free information kit. You'll learn how simply walking on the tread climber can burn up to 2.5 times the calories of other workouts, and without the stress that running puts on your joints.
The doc's like, hey, you've got high blood pressure, you're borderline diabetic. So my wife surprised me with Bowflex tread climber. It did have the low.
So the continuous tuning, it's a nifty feature, but boy, you really gotta kind of tweak this to get the sound just right.
To the tread climber. I lost 40 pounds in just 4 months, and I've kept it on for 2 years. The pounds start going away quicker than you'd imagine. 30 minutes, 3 times a week is really all it takes. Yeah, it's true.
And they mentioned that again in the servicing info. They said to really focus on getting the sound right. And they claim once it's set that the local oscillator is so stable that it won't drift. Alright, let's check out the radio band. Probably work a little bit better if I hooked up an antenna. I'll set up a quick dipole. I just hooked a couple, 2.5 foot long pieces of wire to either of the antenna terminals. That sounds really nice. Just with a TV though, you gotta be right on the station. Nice thing about with this tuner design though is when you're switching through and there's actually like a cam in there that shifts a switch over, and there's 3 positions: low VHF, high VHF, and FM. And when you hit FM, it actually kind of spreads things out, so makes tuning the stations a little bit easier.
Winter can be extra tough in your car, truck, or SUV with all the snow.
My baby's dancing, but she's dancing with another man.
I gotta die unless we can next year.
And as I go back the other way, there's the high voltage kicking back in. And so over the air, channel 6. And
Guess my eye. I know who you are. You're a bunch of pirates who've been looting our ships. Easy, lads. Let's not be ungrateful. After all, our host has brought us a fine treasure.
alright, so I'm going to keep fiddling around with it and see if I can get the centering and the distortion of the kernel a little better, but otherwise I'm calling this restoration done. Hope you enjoyed this look at restoring a rather uncommon Mercury CTV-220A from 1951.